This video will show you how to use SPSS to conduct a simple regression analysis. We'll use the vignette GRE scores. Are they good predictors of academic achievement? And in this case, a university professor who taught graduate level courses for the College of Education decided to study the relationship between GRE scores and achievement in graduate school courses. His decision to investigate this relationship was based on comments made by graduate students which suggested that performance on the GRE was not related to their performance in graduate school. So what he did was, in order to look at the relationship between GRE quantitative scores and exam scores in Educational Statistics 1, he collected exam score data, and then he collected the GRE quantitative scores from the students in his classes with their permission. And so if we look at that data and how it's set up in SPSS, we see that we have a quantitative score for each exam score. So these scores are paired. And in this case, we're not going to use the verbal at this time because really the question is about the relationship between quantitative GRE results and then a quantitative graduate level course. So what I'm going to do is go ahead and run this analysis and then we'll interpret it. And so I'm going to go to Analyze, Regression, and Linear. And what I'll do in this case is exam is going to be my dependent variable, and GRE quantitative scores will be my independent variable. And then for my statistics, I want to check descriptives because I want to get the means and the standard deviations. And then I can simply run the analysis. And so in this case, I get the mean for the exam, 68.9 in the standard deviation. And then for the GRE quantitative scores, I get the mean and the standard deviation as well. The correlation between the GRE quantitative scores and the exam scores is very high, 0.85. And if I go to the model summary, you can see that the R square in this case, because it's a bivariate linear regression, the R is the same as the Pearson correlation here. But then the R square is 0.731. So 73% of the variability in final exam scores from Educational Statistics 1 are explained by GRE quantitative scores. And then my standard error of estimate is 6.44, and I'll come back to that in a minute. We can see that we have an ANOVA summary table here, and this result is significant. So what it means is that the GRE quantitative scores collected from students are predicting educational statistics final exam scores beyond chance levels. Then these are the coefficients. So here's the constant, minus 75, and here is the slope for the GRE quantitative scores, 0.969. And these are the coefficients that you can use to create the regression equation. We also can see that the coefficient, the unstandardized and standardized beta coefficient for GRE quantitative is significant. In other words, it significantly contributes or it significantly explains variability in final exam scores. Now let's come back up to the standard error of estimate. The standard error of estimate helps us understand how precise our prediction is in terms of predicted GRE scores. So one of the things I can do is I can go back up to Analyze and Regression and Linear, and under Save I can save the unstandardized predicted values. And if I go continue and OK, I get my output again, but now I get the predicted values based on the GRE quantitative scores. So I'm just going to move those right over here so we can look at them. So now let's take a minute to look at the importance of the standard error of estimate. Our standard error of estimate is 6.44. Now that tells us how variable our or how precise our estimate is of these predicted values. And the higher the correlation between the dependent and the independent variable, the smaller the standard error of estimate, the more precise our predicted values are. And what I've done here is I've taken and I've calculated the 95% confidence interval based on our standard error of estimate. So for any predicted value of y, that's what y hat means. Our standard error, our 95% confidence interval is z, which for 95% is 1.65 times our standard error of estimate. And so 1.65 times 6.44, which is our standard error of estimate from our output here, is 10.63. So if we go back to our spreadsheet, we can see that any of these predicted values, so this is 51.9 or almost 52, plus or minus about 10 point, I think it was, what was it, 10.6. Here, 60 plus or minus 10.6. So even though we have a high correlation between GRE and final exam scores, we have quite a bit of variability in our preciseness of estimating those scores. So this is just a little tutorial on how to do the regression analysis for the homework assignment. Please let me know if you have questions.